and I'm not going to require you to check all your answers all semester. In fact, I'll make you a deal. I will have you do it tonight, or on this assignment, 2-1, 2-2, and the beginning of 2-3 is your assignment for tonight. I'll never ask you to do it again. You can do it if you want to. It can be a great tool, but I want you to learn how to do this and get some experience with it tonight. Sometimes checking your answers can be problematic. We're going to discuss that in our next lecture. So now we take our original problem, x over -2 equals -12. We determined that x equaled 24, therefore when there's an x we put on a 24. 24 over -2 equals -12. 24 divided by -2 indeed is -12. That equals -12. Check. That is a true statement. Okay? That's the multiplication or division principle. All right. Let's kind of review a little bit of what we've talked about here. If you can bring the camera all the way back here, Nicole. Okay. I left everything on the boards so that we can go over this and see sequentially how this works. The balance rule. The balance rule is our greatest tool of manipulation. Okay, so this is our greatest tool of manipulation. Now remember, math is the manipulation of numbers to look different but remain the same. If I'm going to manipulate equations, I have to have a tool that allows me to do that. The balance rule allows us to manipulate equations. When we come here, this is the full process that allows us to solve equations. Our goal is always to get the variable all alone. We're discussing this next time, how to clean up a dirty equation. It's kind of like a dirty bomb. Don't talk about that. Dirty equation. Okay? We're going to, though, in this section, yeah! Nicole's laughing. Yeah, the camera girl's losing it. Okay, addition and multiplication principles, all you're talking about in this lecture. What governs what we do with the addition and multiplication principles? We're asking every time, who is sharing sides with x? Because our goal is to get x alone. What are they doing to x? And then we're going to do the opposite to both sides. So here we had examples of the addition principle. Things being added or subtracted to our variable are the things we're going to take care of in the addition principle. Things that are being multiplied or divided to our variable are things we're going to take care of in the multiplication principle. So now I want to put these two principles together. So by the way, this is section 2.2. So I'm actually going to erase this, okay, so that Nicole's camera action can get everything we need. All right. So the next thing we do is we put the principles together, use them together. Notice, Nicole, if you would, can you see the three-step process to solving over there?
Yeah.
Notice that we are doing the addition principle first and then the multiplication principle. It's really important that we follow this order. It'll make our lives much easier and it'll make the math easier to deal with. So let's say that I have an equation like 2x plus 12 equals, and I'm going to say 14. Okay, 2x plus 12 equals 14. So now we have more than one thing sharing sides with x at the same time. So who is sharing sides with x? That's right, both 2 and 12. So we must do the addition principle first. So we're asking who's being added or subtracted to x. Indeed is 12. It's being added, so we are going to subtract. So 2x plus 12 equals 14. I'm only writing it again just so you can clearly see the original problem before I start messing with it. I'm going to subtract 12, okay, to get rid of 12. Because remember, 12 is being added. I'm going to do the opposite. But what I do, I got to do to both sides. Balance rule, okay? And these cancel. And I have 2x equals 2, okay? Now, 2x equals 2. Who's sharing sides with x? 2 is. It's being multiplied, so we are going to divide. 2 divided by 2, 2 divided by 2. These cancel, and x equals 1. And again, we can check our answer. getting